and welcome back. Here I have two items. They look pretty different. This one's see-through, this one isn't. I can even see my reflection in it. But did you know that on a chemical level, they're actually very similar, even though they look kind of like opposites to us? Stay tuned to learn more about some of the big differences that a little change on a microscopic level can make. So, do you know what these are? Well, this is a lens, like you might see in a pair of glasses or in a magnifying glass. So it's made of glass, but what even is glass really? Well, actually it's essentially sand that has been melted down. You wouldn't find glass forming on your local beach, however, because it has to be heated to extremely high temperatures, over 3,000 degrees Fahrenheit. There are many different types of glass, but this one is called silica, which is a combination of silicon and oxygen. Now, how about this one? What do you think it is? A mirror? Well, that depends on your definition of a mirror. It's certainly reflective like one, but it's not the kind of mirror that you would find in your bathroom. This is actually a thin wafer of polished single crystal silicon. I know the name sounds similar, silica, silicon, but as you can see here, the materials are actually very different. So silicon is a pure elemental substance, and it's actually what you use for making computer chips. And these computer chips are what makes the electronics in your computers and smartphones possible. So here is a similar wafer, and on this one we've printed computer chips. So these little squares would just be cut out and they would go into these electronics. They use this material in computer chips because it is something called a semiconductor. If you recall, a metal is a conductor, meaning that electricity can pass through it very easily. The prefix semi means half or partially, so a semiconductor still conducts electricity, but just not quite as well as a metal. This is actually perfect for electronics because the flow of electricity needs to be controlled and steered in certain directions. This is much harder to control in a normal conductor, like a metal. So, as you can see, the chemical makeup of a material has a huge effect on its properties. Have you seen this chart before? This is called the periodic table of the elements. It's a visual way to organize all of the smallest chemical components, known as elements, that scientists are aware of. Everything in the universe is composed of one or more of these elements, and this is a very important tool for chemists. So remember that I said the wafer was pure silicon? That's right here on the table, abbreviated Si. And the lens is silicon with some oxygen, abbreviated as O, which is right here. So what's different between the reflective wafer and the transparent lens is just the addition of oxygen. Now remember that thermal camera that we used in a previous video? It takes photos using infrared light rather than visible light. In these side-by-side videos, I'm holding either the silica lens or the silicon wafer, and you are looking through an IR camera, a camera that can detect the infrared light that is produced by heat but that is invisible to us. Can you see my fingers in one of the videos, but not the other? In which video do you think I'm holding the lens and which has the wafer? Well, let's take away the infrared camera. Did you get it right? Remember, the lens was transparent in the visible, and we couldn't see through the reflective wafer, but in the infrared, it's flipped. Optical engineers build materials and systems that harness light. Some optical engineers make the camera lenses that allow you to take photos, as well as other systems by creating and using these materials that interact with light in different ways. They also work with the polishing methods to make surfaces super smooth and reflective like this one. Optical engineers built a lot of the components that make modern technology possible, even in applications where you can't see the light. And if you continue to study math and science, you too can make cool optical technology that is on the cutting edge.